Howdy folks, I'm going to be taking apart one of these utility pumps today. This is a pretty common type design pump. This particular one is made by GSW, part number 306666. Guess that should tell us something right there. It's about 15 years old. I've got several of these pumps. I find them super useful, could not be without them. They've got a hose bib on them. You can just hook a garden hose up to them. They'll draw down quite shallow. You know, most of the time what I've had happen with this one, this is my outdoor one, I use it for a pond and pumping out puddles in the yard and stuff, but they get clogged with stuff and you just have to take the bottom screens off and clean them out. But the last time I tried to turn this thing on, it just hummed, wouldn't turn. So I thought something was in here, so I just got my screwdriver and the impeller was completely seized. I thought something was seizing it, but then 2 days later, same thing. I've got it seized or unstuck now, but listen to this thing. Just gross. So I'm guessing the bearing shot. Now I don't know if you can replace the bearing or not, but I thought it'd be interesting to open one of these up. Like I said, these things are still being made. I know up here in Canada, Princess Auto's got one. That's basically the same specs, looks identical. I've also seen them online, so they're still making them. And they're neat little pumps. A lot of times submersible pumps like this, they're oil filled, but these ones aren't. They do have a screw in the top though, and you know, you can take this out to see if there's any moisture in it. Again, there's no oil in these things, but you know, if you were to tip it upside down and water was to come out of that hole, yeah, you'd know it'd be pretty much fried in that respect. So I'm just going to take the base off. There's screws. Once you get the plates off, the screen plates off, you can get these screws out of here. I'm just going to fast forward through this. Okay, and just a very simple impeller. Gasket. How is this held in? Took one of these apart a long time ago. I think this just pops out. Make a liar out of me. There we go. Okay, so let's just get these wires off. Take our ground off. And I think these just are little bullet type pins. Yep. So yeah, you don't even have to take that upper wire cover off, which is a sealed unit. So we'll just put that, and you know, look inside here, see if there's any moisture. This is dry, so obviously the seals are still in good shape. So again, little induction motor. Needs a capacitor for the start to start it, and we'll just unplug that. And I'll take this top cap off, hopefully. Use a flat-bladed screwdriver. I bet you these things are seized solid. Oh, geez. Not at all. Okay, so we'll see if we can take that top cover of this motor off, or if it's seized on there solid. Hammer this. There we go. Carefully pull the wires through the one hole. Before I do that, I'm just going to mark a couple of things. I'm going to mark which way this went on. Not that I think it matters, and I'm just going to mark which hole these wires came out of. And these ones, they'll only hook up the one way because there's a male and a female, and it doesn't matter which side of the capacitor you put the capacitor winding wires on. Okay, well, it just looks like a standard, what size is that, like roller skate or rollerblade bearings. What are those? I've got a whole drawer full of these things if that's the same size, which it is. Don't know if the other one is. This one still feels good. There's a notch in here, which is generally a good indicator to tell you this impeller is screwed on. Now when we look at the impeller, it turns this way. I believe, no, it would turn this way because it's a centrifugal pump. So it's drawing in through the bottom, pushing out through the sides. So if it's spinning that way, clockwise, it's probably a counterclockwise left-hand thread. I'll turn this counterclockwise, yeah. Or turn it clockwise to get it off. Left-hand thread. And what do we got here? Just going to zoom in. Ooh, repositioning. Okay, what's this little thing? Okay, this is the seal, I guess. Okay, it's one of these spring-loaded seals. There's a, oh, it's nasty looking. But actually the shaft isn't chewed up or anything. These when the impeller goes down, this has got a spring in it, and as the impeller, when the impeller presses down, it actually compresses the seal inside, and it really seals tight around the output shaft. So I'm gonna have to clean that out. But oh, yeah, you can tell it's completely. Now, can we get this out? There we go. Oh yeah, and there's the bearing. Oh, just completely toasted. Rough as hell. As far as the shaft goes, it's not too pitted. Hopefully you can see that. Chances are this bearing is going to be a real bugger to get off, because even if I do get it loosened up on the shaft, it's going to hit all this chowder, all this pitted chowder, and it'll probably get stuck on there. So I'm just going to take a fine 3M disc, just quickly remove what I can on here. Don't want to be too aggressive and take off too much material off the shaft. Just get some emery cloth now and polish that up. Okay, so now that I've got that, most of that crap off the shaft. Now this bearing's probably been pressed on, so you can try to take it off. But no, it's not coming off. So you got two options at this point. We can either heat it up with a torch to see if we can expand the inner race enough to slide it off. But I think we'll get out a puller set. See if I've got one small enough to fit on here. Problem is the shaft doesn't have a dimple on it for the center of the puller. Now this looks like a 1/4 inch thread, but of course it's left hand. You could put a nut on there to use the opening in the end of the nut as your centering point. But let me look for a nut and get my puller out. Well, I looked real quickly. I can't find a left hand 1/4 inch nut anywhere in here. The only nut in here is behind the camera. So what I'm going to do, I'm just going to found a couple of nuts that'll just large enough to fit over the left hand thread, but rest on the shoulder. Get another one on top. and then we should be able to use that as the centering hole for our puller. I'm just going to get this hooked up and see if we can get this thing pulled off. Okay, so got the puller hooked up. These are sometimes a challenge to get in, but it looks like it's going to work. Just want to get your 3 ears spaced equally around the bearing. I like trying to hold them. Oh yeah, here she comes. It's not too bad at all. Here's another little trick you could try. Just pan up a bit. Hold the, just get a crescent wrench, snug it across the shaft, and grab your soft blow hammer and give the edge of the, and hopefully that'll, there she comes. Just gonna put a rag under here so it doesn't completely bend the hell out of it. There we go. Oh, crusty. That one's going in the garbage. So, I'm just going to get one of these ones and put it on. Now I'm probably going to have to use a press for that. So I guess I have to go over to the press. You could actually, we might not even have to do that. That wasn't too tight of a fit. So I'm going to show you another little trick here. No proper tools. So what I've done, I've just got a little 1/4 inch long socket. This is a 9mm, but just something big enough to fit over the shaft, yet will press okay on the inner race. Because you don't want to tap it on the outer race, because then you'll bugger the bearing. So you want to press it on with the inner brace. Now I could take this over to my press, you know, and just drive the press down, but like I said, the fit wasn't too tight. Just going to lube the shaft up a bit with some T9 bow shield. I don't know if that's going to help it slide on any better. We'll just get it started like so. We're supporting the shaft, so nothing should bend. Put that over top and start giving her little tappies. Oh, yeah, there we go. And you know what? Well, I've got this thing out. There's nothing wrong with that bearing, but I'm going to pull it off and replace it too. I've got tons of bearings here. Why not? Right. Got another sealed bearing on there, so replace both bearings, and I've cleaned out this outer seal, so we'll pack that with grease here. And also on the inside, this the outside half of the motor sits into. Again, this is just a pretty standard induction motor. It is thermally protected, and there's a thermal switch right there. So if you had one of these and it stopped working for no apparent reason, that's a good little rascal to suspect. But this is metal. Non-magnetic, so it's not ferrous metal. So I'm guessing it's probably cast aluminum. Yeah. This seal inside is pretty interesting. It's got a ceramic ring. There's a double lip seal inside too. So that's what was riding on this part of the shaft here, was that double lipped seal. And then you've got the main seal on the outside, that compression seal. So when the impeller is compressed down, it tightens the seal against the shaft. So I'm just going to put this back together in the reverse order. I'm going to lubricate all the seals up with silicone grease. And as far as the sealing ring, there's two sealing rings for the motor assembly itself. There's a big O-ring around this metal bottom plate, and then on the top there's another sealing ring, and it's actually, there's little notches in here, so you have to line them up with the little notches in the in this bottom case. And I'll lube that up as well with silicone sealant, or silicone lube. And then we'll just, so you've got a double sealing on this as well. On the bottom plate of the motor, you've got the O-ring that seals on the out, or the inside of this recess, and then it also seals against this little lip. So definitely lots of sealing in these. Just looking at this a little bit closer as I was putting it back together, that ceramic ring in there is actually, there's a sealing surface on this sprung seal. And again, I'm just lubing that up with some silicone sealant. I've packed this completely full, not silicone sealant, sorry, silicone grease. And yeah, that rides, because this thing is turning with the impeller. Once that impeller's on there, this whole thing will spin, and this raised lip on this inside portion of this sprung seal, that's what's riding on the on that ceramic ring in there. So that's why they use a ceramic ring. Very low friction and super long life. So this will fit on. Again, this will tighten as if you were taking it off. There we go. Another little tip, probably a good idea to put some grease on the outside of the bearing, the upper bearing as well, because it slides into this aluminum top half, and if water gets in there, yeah, it could get corroded in there pretty good. Probably be pretty hard to get it out. So yeah, I'm just using a regular bearing grease for that. So we got our wires plugged into the capacitor. What is this, 12 microfarad, 250 volts AC. Because these look like they've been corroded, or they've got a potential to corrode, they're also being threaded into that aluminum base. I'm just going to coat the bottom of the threads here with some bearing grease, and I'll coat the head later too. Just fast forward through this. So I think that's pretty much it. I've really greased these two seals up with silicone grease. If this was all dirty, I'm probably going to clean this out. I'm going to use some brake clean, just on a rag. Clean that out. Almost have this little rascal back together. This inner screen, it uses a slightly smaller screw than the base. So if you've got one of these and you're taking them apart, just make sure you make note that the smaller screw is what holds the screen on, or the inner screen section. And I often run this pump in our when I'm pumping out our pond, or just without the base. These little feet still hold it up high enough that water can get into the screen. Then you can draw down the level really low. but most of the time you should probably have the base on as well. Okay. Now another important thing not to forget is to put that vent screw in. And yeah, if you've got one of these pumps, you know, if you only use it seasonally, you know, maybe take that screw out. Just any condensation that gets in there will dry out. But then of course you risk leaving it out and forgetting about it. And again, I'm just going to fire some silicone grease on there. Help it seal hopefully a bit better. Good and snug. Okay, that wasn't a good idea. Silicone grease made the seal so slippery it caused the O-ring to pop. So don't put silicone grease in there. Not a good idea. Or if you do, don't use much, and don't over tighten the nut or the screw. Just make sure that ring doesn't pop out. Okay, hearing is believing. Let's plug it in. Beautiful. So that's how you replace a bearing on one of these beasties. I should mention that they say not to run these dry, and now I can see the reason for that. It's that ceramic, that seal that rubs on the ceramic, that's always being lubricated by water. You know, right now we've got it greased up, but that grease is going to dissipate over time because that's always, that seal is submerged in water all the time. So that's obviously why they say not to run these dry. It's to prevent that seal from, you know, wearing out on that ceramic rim. But it was neat to see that. Cheers, folks. Happy pumping.